Precision in the grinding process is a crucial aspect of manufacturing, directly affecting the quality, accuracy, and performance of the final product. Various factors influence the accuracy of grinding workpieces. Below is an overview of the main factors. 1. Type of grinding wheel and abrasive selection. Different types of grinding wheels have distinct grinding characteristics. Choosing the right abrasive and bonding type is key to ensuring grinding accuracy. 2. Grinding wheel hardness. The hardness of the grinding wheel is vital for maintaining shape and dimensional accuracy. Proper hardness balances self-sharpening and wear resistance, ensuring grinding precision. 3. Grinding wheel grit size. The size of the grit directly impacts the surface roughness and controllable accuracy range. Finer grit sizes typically lead to higher grinding precision. 4. Installation and balancing of the grinding wheel. Correct installation and balance are prerequisites for ensuring grinding accuracy. Poor installation or imbalance can cause vibration and deviation, reducing precision. 5. Clamping and positioning of the workpiece. Secure clamping and accurate positioning of the workpiece are crucial for ensuring grinding accuracy. Poor clamping or positioning can lead to errors and deviations during the grinding process. 6. Dressing of the grinding wheel. Regular dressing of the grinding wheel maintains its grinding performance, but excessive dressing can shorten its lifespan and affect grinding accuracy. 7. Grinding machine accuracy and stability. Advanced grinding machines and control systems provide higher grinding accuracy, ensuring workpieces meet specified size and shape requirements. 8. Rigidity and stability of the grinding machine. The rigidity and stability of the grinding machine are essential for maintaining the stability and precision of the grinding process. 9. Grinding process parameters. Choosing and optimizing grinding process parameters are crucial for ensuring grinding accuracy. This includes grinding speed, feed rate, grinding depth, and the use of coolant. 10. Material properties and stability of the workpiece. The material properties and stability of the workpiece directly impact grinding accuracy. Unstable workpieces may cause errors and deviations during grinding. 11. Cooling system. An effective cooling system can reduce the temperature during the grinding process, minimizing thermal deformation of the workpiece and grinding wheel, thus improving accuracy. 12. Selection and use of grinding fluid. The choice and use of grinding fluid affect lubrication and cooling during the grinding process, influencing grinding accuracy. 13. Thermal deformation during grinding. Heat generated during grinding causes thermal deformation of the workpiece and grinding wheel, affecting precision. 14. Cutting force during grinding. Cutting force impacts grinding accuracy, especially in high-speed grinding, where cutting force influences the outcome. 15. Operator skill level. The skill and experience of the operator are critical for ensuring grinding accuracy. 16. Maintenance of the grinding machine. Proper maintenance ensures the precision and performance of the machine, preventing a decline in grinding accuracy due to machine issues. 17. Environmental conditions. Environmental factors such as temperature and humidity can affect grinding accuracy, particularly in high-precision grinding processes. While the above factors cover the main aspects affecting grinding wheel accuracy, actual conditions may vary based on specific process requirements and workpiece characteristics. Therefore, it is essential to consider various factors comprehensively and adjust and optimize according to the specific situation to ensure the desired grinding accuracy.